Hi, the following tutorial is a lesson under Science Paper 1. Categorically, we are trying to express our tutorial through physics and a focus of work, energy, and power. We cannot just go directly into answering the question without firstly having to understand that we need to define these terms. The first thing is we're going to define work, energy, and power separately. Afterwards, we're going to encounter the question and see how best it would be beneficial for us to know the definitions in order to connect to the formulas as well as the calculations. When we talk about work is able to relate to force and the distance in the line of the force applied. So when we are told to define work, we always say work is the product of force and distance in the line of the force applied, meaning if we are trying to talk about work done, we would probably say force times distance. Since these two are being multiplied, their product is what you're trying to say, work done. And when we talk about energy, it has different forms, but generally, energy is the capacity or ability to perform or do work. We can be able to talk about potential, kinetic, and other forms of energy. Energy is rather said to be the capacity to do work. And when we talk about power, we're trying to compare the time under which a certain work is done. Therefore, we always say power is the rate at which work is done. But work done and energy always contain the same units. Then let's entertain the question. A box is put over a distance of 5 meters by a force of 20 newtons in 50 seconds. Those values are going to play a role in answering the questions that are going to follow. Calculate Roman numeral 1, the work done on the box. The first and the foremost thing in physics is always to come up with the correct formula. So on the solution part, we're going to say on Roman numeral 1, we say work done equals to force multiplied by distance. It would be so relevant and beneficial that besides the formula on the right, we can come up with our data to simply be able to be referred to in case we would want to substitute values. So on the right, we're going to come up with our data. Then we're going to say work done. This is the question under which we're calculating a value. So I'm going to replace with a question mark. Then on the force, we're going to go back to the question. We have 20 and force is given in newtons. So I'm going to replace 20 together with the newton being the exact units. Then for D, we're going to say 5, then meters. Having done that, we're going to substitute in the correct values from the data into the correct formula on the correct positions. So we're going to say work done equals on force, we're going to say 20. And it will be relevant in order to substitute a value attached with units to correspond with what's being described as a value. So if we're trying to talk about force, we replace together with newtons multiplied by distance, 5 meters. So work done equals 20 multiplied by 5 is 100, and then we replace Newton meter. But Newton meter then brings in the realization that those are the units for moment, and in as much as we are talking about work done, it's the same as compared to energy. Hence, we're going to say work done equals 100. 1 Newton meter is equivalent to 1 joule. So this becomes 100 joules. Then we go to the second one, where we're going to say Roman numeral 2. And the question says the power developed on the box. We firstly had to define power, where we said power is the rate, which means time, under which a certain work should successfully be done. The power developed on the box, we're going to say power equals to energy over time taken. Then we're going to find that energy is not given, as it's neither potential nor kinetic or any other form of energy. But what we calculated first can be placed on energy and it's in form of work done. So I'm going to change the formula where it's going to become an energy. We're going to say work done over time. So power then is going to be, we had calculated the value So this becomes 100 joules over the time taken from that question is 50 seconds. So I'm going to say 50 seconds. And lastly, we're going to say power equals, we cancel the 0 and the 0. 5 into 10 becomes 2. We start with the units on the upper position, joules per second. The correct units for power under work, energy and power are joules per second. Had we been talking about electrical power, we would have been able to put watts. Ensure you use the same very concept to prepare adequately for an exam, probably section B of science paper 1, and invest your time in proper practice in order to build self-reliance. Ensure you grab the paper, you pause where you haven't understood, and be able to create a time to go through consistently in order to see a positive change. This has been Mr. Sensor, your tutor from Sensor Academy Competitions. For now, till in the next video, it's a very goodbye.